of the data protection lifecycle in Snowflake, which is failsafe. So failsafe serves as a data protection mechanism for our data in case of a disaster. This means if we lose the data or if it gets corrupted due to some kind of a disaster event, failsafe allows us to recover this data. The important thing here is that the data will be in this failsafe area, but we cannot configure this. So this is a non-configurable 7-day period for the so-called permanent tables. So this is just the default type of tables. Most of our tables are permanent tables, and we talk about the table types also in more detail later on. So this period of 7 days just starts after the time travel period has ended. So once the time travel period ends, the data from time travel just moves into the failsafe area from where we can restore it. To be more precise, it is not us that is restoring this, because this is the next important point. We are not able as users to interact with the failsafe. This is nothing that we can restore here from, but we have to reach out to the Snowflake support that we need to recover this data. So this is something that is different from time travel. So this is why it is also just a disaster recovery. So if we have no other way, and this is hugely important data, then we should reach out to Snowflake and it will be recovered. And in regards to the cost, it is the same like with time travel. It just contributes to the storage cost. So when a table or some data is moved into the failsafe zone, then it will just contribute to our overall storage cost and we will pay for this storage. So let's talk about a little bit how this would work. So we have, of course, our current data storage in Snowflake. This means our active storage. These are our tables that are visible to us. We can query them. And then we have, of course, also afterwards the time travel period or the time travel storage, basically. So depending on what we have set up for our tables, which period, we store all of those previous versions or changes of the table in this time travel zone, basically. And here we can also, as users using select at or before or undrop if something has been dropped, we can access this data. And then once the time travel period ends, the data automatically moves into the failsafe zone. For example, if we have 1 day retention time, after we have made some changes, after 1 day, those changes, so the data that is related to those previous versions, those changes, moves into failsafe. And this process is automatic and there are no user operations allowed here, so we cannot influence this like by manual operations. And also we can not access the data in failsafe ourselves. So this is something that can only be done by reaching out to the Snowflake support. And here we have now in this failsafe 7 days beyond the time travel period for those permanent tables. We also have transient tables. Again, we talk about this in other lectures. They have 0 days in failsafe. So there's no failsafe for those transient tables. And they are mostly used, those transient tables, for development purposes, just to save some storage costs. We make maybe lots of changes there and we are not, it's not productive data that needs to be recovered. So therefore we have those type of tables to just save some storage cost. And here, we just don't have this level of protection needed that is offered by failsafe. So you see that this failsafe is part of the data protection lifecycle. And now, of course, we want to have a look at our account to see how the storage is, how this works in Snowflake in our account, and most importantly, of course, how we can monitor this. So we want to understand how this works, and as we cannot operate on this and interact with this actively, we want to focus on understanding how this works, and of course, most importantly, how we can monitor this. So we want to see what are some ways of finding out about the failsafe storage, what tables are consuming it, how we can monitor this in a good way. And we have 2 ways of doing this. Number 1 is, of course, using the interface, which we will have a look at in the beginning. And then also we will have a look at some interesting views that we can query to get more detailed information about failsafe consumed in our account. So let's first of all make sure that we are using actually the role account admin so that we can really see all of this what we want to see. And then we can navigate into the cost management. So you can just go back also to main, and then under admin, you will also find cost management, and then you can navigate to consumption. And in here, we want to, of course, switch to the storage. So that's what we want to have a look at. And don't worry if you select this now for the first time, it might take a couple of seconds to be loaded, but then you will see here this consumption, in this case, broken down by the days. So you can also, of course, switch this. If you have more data there, you can also select your type or account. We only have, of course, one account, and therefore, if we select this, we can get a little bit more information. So in this case, it will be also broken down by the object. In this case here, we have this our first DB that is consuming most of this. And of course, again, you can see this broken down by the different types, and then here also by the days. So you can see that here database is a lot. And by the way, this database storage also includes the time travel. So this is both the active data in our current databases plus also time travel. And then we have here failsafe. So you see that after maybe there was a table that was dropped, and then after 1 day it was still in the database storage, and then after 1 day, so once the time travel period has ended, this changes or this drop table just moved into the fail-safe zone, and then here one more. So you can see that now for 7 days we will see that this will reside in the fail-safe zone, and then also 7 days later, it will be also removed again from failsafe. So like this, we maintain always the data from the 7 days period that is after the time travel period has ended. And in here also, by the way, we can select the database and break this down by the database and the date. But sometimes we want to have even more detailed information. So we want to, for example, have a look at how this is broken down by the tables. So which tables are consuming which storage. And to do this, we want to navigate into the worksheets again and have a look at a few interesting queries. Again, make sure that you are selecting the account admin here, because if you use the public role, for example, in our case, we want to query this account usage view. So if I select the public role, you will see that this will disappear and we actually don't have access to this. So therefore, let's just make sure that we select the account admin so we can do everything easily. So first of all, we want to have a look at the storage usage on the account level. So if I run this query, I can order it by usage date. If I want, I can aggregate it and so on. So here we are just a bit more flexible, of course. And then we can see here also the usage date. We have the storage bytes. Again, this is just in this case the time travel plus the active together. And then here we have this broken down into stage bytes, failsafe bytes, and then here also the hybrid table storage. So this is now broken down by the days and then also by the type. And if we want to organize this a little bit nicer, so we want to format it a bit nicer, we can also see it here in gigabytes. So we just basically divide it by gigabytes to just convert it into gigabytes, and maybe we name it a little bit nicer and just focus on what we are interested in. So you can also see pretty much the same data here as in the interface that we have just seen. So therefore, if we now want to query the table storage metrics view, we get more detailed information on the table. So on the table level, how much storage is used here. So if I select this query, I can see now here this ID, so this table ID, and then here the table name. So again, you can see we have maybe multiple tables with different IDs. So this ID is there to uniquely identify each table. Even if they have different names, or the same name, they can be different tables actually. So of course, we can drop a table and then create it with a new name. Then with the same name, then this is a different table, but it is just having the same name. And also in here, we can see the active bytes, we can see time travel, and here also, for example, failsafe bytes. And if we now want to just have a look at how much is consumed now by failsafe. We can also now just order it in our query by the failsafe storage used. And in this case, we can see now which table is contributing so much to our failsafe zone. So in here, I can see this is actually this orders caching table. So this was a pretty large table. And if we scroll to the right, currently we have 1.1 gigabyte in storage. And then here we have in failsafe storage 2.1 gigabyte. So here probably we have dropped it. The time travel period has ended. And then we see that this has now moved into the failsafe storage. All right. So this was it about failsafe. This is just part of the data protection lifecycle. And if we want to recover it, we have to reach out to Snowflake support. So this is disaster recovery. And we should be careful with having the storage in here. And this depends on the table types. So we have mentioned the transient tables, for example, they don't have failsafe. So we can use this if we have huge tables and we don't want to have the data protection with failsafe to save storage. We can use those transient tables. And of course, what are those different table types? Transient tables, temporary tables, permanent tables. Let's now